Hello guys, welcome to another video, and in this video we are going to be configuring, and we are also going to go over a couple of PowerPoints that I have. Like you guys know, I don't really like doing just PowerPoints. I like to configure everything. So I'm going to be going over IKEV1 and IKEV2 and how they are different and all that good stuff. So it's going to be a little bit of a long video. So if you don't have time, just go ahead and save this video and watch it later, because it is going to be long. Or you guys are going to see it because you guys are going to see the time on YouTube, right? So let's go ahead and start IKEV1 versus IKEV2, as you can see right here. And this is basically, let's see if I, there we go, percent. This is basically the battle to secure IPsec. What is IKE, guys? Well, IKE is IKE stands for Internet Key Exchange, and is a key management protocol that is used to authenticate IPsec peers, negotiate and distribute IPsec encryption keys into automatically established IPsec security associations, or SAs. That's what they call it. And it's IKE. And IKEV1 is also called, I should have put right here, IKEV1. It's also called Internet Security Association and Key Management Protocol, or ISAKMP. And there's two types. Version 1, which is this one right here, Internet Security Association and Key Management Protocol, ISAKMP. And we have version 2, or IKEV2. And like Cisco calls it Flex VPN. Don't ask me why. And IKEV1, the IKE Version 1 negotiation comprises of two phases. Phase 1 negotiates a security association between two IKE peers, which enables the peers to communicate securely in Phase 2, and Phase 2 is IPsec. During Phase 2 negotiation, IKE establishes security associations for other applications such as IPsec, which is done in Phase 2. Phase 1 has two modes. One is main mode, and the other one is aggressive mode. The default mode is main mode. Main mode versus aggressive mode. Well, as you can see right here in this picture, you can see how many messages are exchanged. As you can see in the main mode, you can see that there is more stuff that are being negotiated. In aggressive mode, there is less stuff, therefore it is faster. But the bad thing about aggressive mode is that it does not encrypt anything. Everything is sent in clear text. But in main mode, everything is encrypted, and the hackers or whoever's sniffing the network cannot see the parameters that are being exchanged. Phase 1 sets up mutual authentication of the peers, negotiates cryptographic parameters, and creates session keys. The Phase 1 parameters used by DNSSEC are the following, or by any layer 3 device, like a router or a layer 3 switch. You can use triple DES, AES-128, AES-256. You can also use AES-GCM. You cannot use AES-GCM, because it is not supported in Phase 1. But you can use it for Phase 2, which is IPsec. And this is for data encryption. Then we go ahead and configure either SHA-1 or SHA-2 for data integrity. This is the hashing algorithm. Then you can go ahead and configure the Diffie Hellman group number, either 2, 5, 14, 15, or 16. Either one of those. For authentication, you can use pre-shared key, which is a secret key, or you could use a digital certificate. And the lifetime for that is 2800 seconds, or 8 hours, with no live bytes rekeying. In ISAKMP, aggressive mode is disabled. Therefore, the main mode is the default mode. And then we go ahead and move to Phase 2 of IKEV1. And Phase 2 for IKEV1 and IKEV2 is the same, which is just configuring an IPsec. And IPsec provides data encryption at the IP packet level and offering a robust security solution that is standards based. The IP security or IPsec is a standard suite of protocols between two communication points across the IP network that provide data authentication, integrity, and confidentiality. It also supports anti-replay if you use ESP, which we're going to talk about later, ESP and AH. It also defines the encrypted and decrypted and authenticated packets. The protocols needed for secure key exchange and key management are defined in it, which we're going to do later when we start configuring IKEV1. In the phase 2 parameters, which is IPsec, the parameters that you could do from here, and this is for phase 2, you just encrypt the data that is going to go across, because the phase 1, which is IKEV1 or IKEV2, it just encrypts that tunnel that is going to be IKEV1 phase 1 encrypts a tunnel where phase 2 is going to get on, which is IPsec. And in IPsec, you can also encrypt that data using TripleDES AES-128, AES-256, and AES-GCM. And like we said before, AES-GCM is now supported in IKEV1 phase 1. And you can also do for integrity, SHA-1 or SHA-2. And the tunnel modes, you could either do ESP tunnel mode or AH. It also have perfect forward secrecy for rekeying. And here's the SA lifetime of 3600 seconds or 1 hour. We know live bytes rekeying. Selectors for all IP protocols, all ports between the two networks using IPv4 subnet. And what is the difference between ESP and AH? And this is done in the IPsec, because IPsec has two modes, like we said over here. ESP has ESP tunnel mode or AH mode. In ESP, which means encapsulating security payload, it provides data integrity, encryption, authentication, and anti-replay functions for IPsec VPN. And ESP also authenticates the data within the VPN, ensuring data integrity that it coming from the correct source, right? And for authentication header, provides data integrity, authentication, but this is incorrect because it does not, an anti-replay function, it doesn't provide anti-replay functions. I don't know why that is there. I put that incorrectly. But yeah, the difference between ESP and AH is that AH does not provide anti-replay functions like ESP does, and that's why nobody configures IPsec with AH. Everybody does it with ESP because ESP provides data. It provides anti-replay, which the authentication header does not provide. So let's go ahead and configure IKEV1 since we are done talking about IKEV1. So we're going to go to my EVE and G topology. I have configured all the IP addresses over here. So let's go ahead and do that. This one is going to be IKEV1 right here, and over here is going to be IKEV2. So let's go ahead and go hop on R11. Like I said, I have configured all the IP addresses. So if you do a ping to 10.1.1.2, we should be able to ping it. Good. Config T. So for IKEV1, the first thing they need to configure is a policy. So you can do a crypto ISAKMP. We do not call it IKEV1. We call it ISAKMP policy, and you can name the policy whatever you want, either 1 through 10,000 policies. This is how many policies you can have. You can have up to 10,000 policies. But we are going to configure policy 1. And from over here, if you do a question mark, we are going to provide the authentication, the encryption, different group number, hashing, and also the lifetime. So let's go ahead and do authentication. We are going to be using a pre-share key. Encryption, we are going to be using, let's just go ahead and use 3DES. For hashing, we are going to use SHA. Different group number, we are going to use 2. And the lifetime, we are going to keep it the default, which is 86.400. So that is done. We have configured IKE version 1 policy. So since we are going to be using the authentication, we are going to be using a pre-share key. We need to go ahead and configure that pre-share key now. And this needs to match between the R11 router and the R13 router. If this does not match, we won't be able to authenticate or create that phase 1 tunnel, so IPsec can be created afterwards. So if IKE version 1 phase 1 is not created, then IKE version 1 phase 2, which is IPsec, is not going to be created either. So let's go ahead and create that crypto ISAKMP key. And we are going to just say the key is going to be CCNP security, and it's going to go to the address of 20.1.1.2, which is the IP address of router 13. So we are done with that now. What we need to do is configure IKE version 1 phase 2. And what is IKE version 1 phase 2? IKE version 1 phase 2 is IPsec. So let's go ahead and do crypto IPsec transform set. We are going to name this tset. We're going to use ESP because we're not going to use AH. AH does not provide enter replay. So we want to do ESP AES 256 ESP SHA, and we are also going to be using HMAC. And the tunnel mode, or the mode that we're going to be doing for this, is going to be tunnel exit. If I know how to spell exit, there we go. So after that is done, we need to go ahead and create the IPsec profile. And inside this IPsec profile, we are going to attach the transform set, and then we are going to attach that IPsec profile to our tunnel interface. So let's go ahead and do that. Crypto IPsec profile. We are going to name this just IPsec profile. And all we need to do is set the transform set. So we need to attach the transform set that we created. And that's it. We are done with IKE version 1 phase 1 and IKE version 1 phase 2. After that is done, we are going to create a tunnel interface. We are just going to call it tunnel 0. And from over here, we need to specify the source of the tunnel, which is gigabit 00. As you can see right here, that's the one connected. Then we need to specify the destination. The destination is going to be 20.1.1.2. The tunnel mode, which is GRE, which is not GRE, because if you use GRE, it's not going to use IPsec. So we want to do IPsec over IPv4 because we are going to use an IPv4 IP address. Then we can just go ahead and configure the IP address of this interface, 192.168.0.1/24. After that is done, you can do a do show run interface tunnel 0, and you can see my configuration. You could also do a do show interface tunnel 0, and you can see more. Over here, you can see the IP address of it. You can see that the protocol is down. You can see the tunnel source, which is gigabit 00. You can see the destination. You can see the MTUs. You can see the bandwidth. You can see a lot of stuff from here. After that is done, what we need to do is we need to go ahead and attach the tunnel protection IPsec profile, and we name our IPsec profile just IPsec profile. There it is. So now ISAKMP is on. ISAKMP, what ISAKMP stands for? IKE version 1. Good. So now we could just end it. You can do a show crypto ISAKMP SA, and you can see the security associations, and you can see that we have one right now, which has no state, and it's saying that it is active, but nothing is happening because we have not configured on router 13, and that is for IKE version 1 phase 1. If you want to see IKE version 1 phase 2, you can do a show crypto IPsec SA, and you can see right here the peer, which is a remote IP address of router 13. You can see the local address, which is 20.1.1.1 of router 11, you can see that we haven't received any packets or anything like that. After that is done, one last thing that we need to do is that let's go ahead and do show IP interface brief. Since we are using a that tunnel interface, which is SVTI, we are able to do a dynamic routing protocol. So we are going to go ahead and do a router EIGRP, and we're going to configure EIGRP 10. Let's go ahead and do now the summary. Then we are going to add network 1.1.1.1, which is the IP address of my loopback address, and then we need to add the tunnel address also, or the tunnel network .0.0.255. End it. There we go. So now we are done with router 11. Now we need to do the same for router 13, and we need to just configure router 13 so we can communicate with router 11. Enable config T. What do we need to do first? We need to go ahead and configure IKEV1 phase 1, which is the policy, the pre-share key, and then we need to configure the IKEV1 phase 2, which is IPsec transfer set and IPsec profile. So crypto ISAKMP policy 1, and this needs to match with the same parameters that router 11 has, which means authentication. We are going to use a pre-share key. Encryption, we using 3DES. Hashing, we using SHA. Diffie Hellman group number, we using 2. Lifetime, we need to do the default, which is 86400. Then we are going to do a crypto ISAKMP key, and this key also needs to match CCNP security, and the address needs to be the remote IP address of router 11 10.1.1.1. We are done with IKEV1 phase 1. Now we need to go ahead and configure IKEV1 phase 2, which is IPsec. So crypto IPsec transfer set, T set, ESP, and this one also needs to match 256 ESP chat with also HMAC. Mode is going to be tunnel mode. Exit. Then we are going to go ahead and configure the IPsec profile and IPsec, and the name does not need to match to router 11, so we're just going to keep it the same just because. There we go. And inside here we need to set the transform set to T set. Exit. Now we need to go ahead and configure the interface tunnel 0. The tunnel's number does not need to match, so you can just do a tunnel 1 for this one, and that is fine. We need to specify the source, which is gigabit 00. Tunnel destination, which is 20.1.1.1. Tunnel mode, which is IPsec with IPv4. And what else we need to do? We need to do the tunnel protection, IPsec profile, and we need to attach the IPsec profile that we created. One thing that we are missing is the IP address, so let's do IP address 192.168.0.2. Then we go ahead and do the router EIGRP, and this needs to match for the autonomous system number 10. Then we are going to do no outer summary. Let's go ahead and do show IP interface brief, so we can see which IP address we need to add. So we need to add IP address of this loopback and this IP address of the interface tunnel. Network 3.3.3.3, and then network, and then after we add this network, we are going to form a neighbor relationship with router 11. There we go. EIGRP. So now if we do show IP EIGRP neighbors, we see that neighbor over here, 192.168.0.1. If we do a show crypto ISAKMP SA, you can see that association that we have right here. And this is for IKEV1 phase 1. If you want to do or see IKEV1 phase 2, you can just do IPsec SA. And you can see right here we keep sending packets because of EIGRP sends a hello message, I think every 10 seconds. And that's why we see the data is being encrypted and decrypted. You can see the current peer, which is this one. We are using port 500 because we're not using NAT traversal. If we were using NAT traversal, then this one was going to become port number 4500. Okay. So if you do show IP route, you can see that we have a route to 1.1.1.1, and this is going via 192.168.0.1, and it's taking the tunnel 1. And since it's taking the tunnel 1, it is going to be encrypted, right? You can also do the same for router 11. If you do a show IP EIGRP neighbors, you can see that neighbor. Show IP route, you can see the route to 3.3.3.3 via 192.168.0.2, and it's taking the tunnel. If it is taking the tunnel, it is going to be encrypted. If you do a show crypto ISAKMP SA, you are going to see that security association between the two routers for IKE version 1 phase 1. If you want to see IKE version 1 phase 2, you can do show crypto IPsec SA, and here it is. All right, so that's good. We are done with IKE version 1 phase 1 and IKE version 1 phase 2. So now let's go ahead and talk a little bit about IKE version 2. So IKE version 2. Well, IKE version 2, or the Internet Key Exchange version 2 protocol, dynamically establishes and maintains a shared state between the endpoints of an IP datagram. IKE version 2 performs mutual authentication between two parties and establishes the IKE version 2 security association. And it only has one mode. Remember, in IKE version 1, we had two modes, which was main mode and aggressive mode. Main mode encrypts everything. Aggressive mode does not encrypt anything. It sends everything in clear text. And the default mode for IKE version 1 is main mode. Okay, so in quick mode, it's similar to an aggressive mode IKE negotiation, except that negotiation must be protected within an IKE SA. Quick mode negotiates the SA for the data encryption and manages the key exchange for that IPsec security association. And a lot of folks do not know really how to configure IKE version 1 phase 2. For IKE version 1 phase 2, you have to configure a proposal and a policy, but a default exists, so we are going to use a default for that. You also need to configure the policy, and there is a default for it, and we are going to use the default. You also need to configure the IKE version 2 keyring, which is mandatory since we're going to use the PSK or pre-shared key authentication, and also need to configure the IKE version 2 profile and the IKE version 2 transform set, or IPsec transform set, and IPsec profile for IKE version 2 phase 2. So this is just for IKE version 2 phase 1. And for this configuration, whenever you configure the keyring, you need to attach it to the profile. Then we configure the transform set, and then the IPsec profile. And inside the IPsec profile, we need to attach two things: the IPsec profile, which has the keyring already attached to it, and then we need to attach the transform set, which you guys are going to see later on. And what is the difference? How like IKE version 2 differs from IKE version 1? Well, the first one is that IKE version 2 fixes the style cookie mechanism. IKE version 2 has fewer rounds trips in a negotiation than IKE version 1. IKE version 2 transform, it has the transform options are OR ED, which means that you can specify multiple options in a single proposal rather than creating a separate unique proposals for each allowed combinations. I'm going to show you that. Also, IKE version 2 has a built-in dead peer detection. IKE version 1 does not. IKE version 2 has a built-in configuration for payload and user authentication mode. IKE version 2 has NAT traversal built in. And IKE version 2 uses a single security association that can protect multiple subnets, which improves scalability. And you can also use a asymmetric authentication in side-to-side VPNs, where each side of a tunnel can have different pre-shared keys and different certificates, or one side a key and the other side a certificate. Either way, in IKEV1 you cannot do that at all. And this is it for this PowerPoint. So now let's go ahead and configure IKEV2, and you can see how different IKEV2 is. So let's go ahead and go into EVE, and we are going to start with router 12. So let's go ahead and bring up router 12. Okay, enable config T, and like I said, the first two things I need to configure is the IKEV2 policy and the IKEV2 proposal, but there's a default for each one of them. And if you want to see it, you can do a do show crypto proposal, do show crypto proposal. I think that's how it is. Let me see policy. Am I doing this incorrectly? Show crypto IKEV2 proposal. There we go, IKEV2 proposal. You can see the proposal, and the difference between the IKEV1 and IKEV2 proposal is that in IKEV2 you are allowed to have multiple combinations. As you can see right here, we have the AES CBC 256 encryption, and if that router does not have that encryption, then we can support 192. If they don't have 192, then we can support 128. In IKEV1, you will have to configure a different proposal for each option that you want. But in IKEV2, you can have different options in the same proposal. As you can see right here. Here's the default. And if you want to see the default policy, you can just do policy. And here's the default policy, which has the default proposal attached to it. Okay, let's go ahead and go to config T. And since we are not going to configure the IKEV2 proposal or the IKEV2 policy, we are going to just use the default. So we are not going to touch any of that. And since we're not going to touch any of that, the next step is to configure the IKEV2 keyring. So let's go ahead and do that. Crypto IKEV2 keyring, and we're going to just call it IKEV2 keyring. There we go. And inside right here, we need to specify the name of the peer, which is router 14, and then we need to specify the IP address of that peer, which is 30.1.1.2, as you can see it over here. And after that, we need to do a pre-shared key for the remote. And what we're going to be using, since the remote, you can use different keys for IKEV2. For IKEV1, you have to use just one set of keys, but for IKEV2, you can use two set of keys. For the remote user, it's going to be 14, and for the local user, we are just going to say local, and we're going to say R12. So this needs to match on router 14. So on router 14, we are going to have the remote key, which is going to be router 12, and the local is going to be R14 key, or then that's going to be the pre-shared key. All right, so after that is done, we need to go ahead and configure the IKEV2 profile. And the way that you do that, you need to, let's go ahead and exit and do a crypto IKEV2 profile, and we're going to name this IKEV2 profile. And inside right here, we need to do the authentication. For the local, is going to be using a pre-shared key. You can either do a pre-shared key, you can use a ECDSASIG, EAP pre-shared key, or RSA. We are going to be using pre-shared key. The authentication for the remote is also going to be using a pre-shared key. And you could either use a pre-shared key for the local and a certificate for the remote, or a certificate for the local and a pre-shared key for the remote. But since we're using pre-shared key for both, we are going to specify that we're going to be using a pre-shared key for both of them. After that's done, we need to do a match identity remote address, and we need to add the address of that remote device, which is this one right here, which is 30, that one, that 2. Then we need to do the identity of the local, which has the address of 30, that one, that 1. Enter. Good. After that is done, we need to go ahead and attach the keyring, the local keyring that we configure, and we name this IKE version 2 keyring. There we go. So now we are done with the IKE version 2 profile. And since that is done, we are done with the IKE version 2 phase 1. Now we need to go ahead and configure IKE version 2 phase 2, which is the IPsec transform set and then the IPsec profile. So let's go ahead and exit, and let's go ahead and do crypto IPsec transform set, the first one. We are going to be naming this T set. We're going to use ESP AH, and this needs to match, guys. Okay, if this one does not match, we won't be able to form that phase 2 of IKE version 2. ESP SHA with HMAC. As you can see, the IPsec is not changing. The only thing that is changing is the configuration of the IKE version 1 and IKE version 2. IPsec stays the same. Okay, so we are done with that. Then we need to do a crypto IPsec profile. We are going to name this IPsec profile. And inside here, 2 things that we need to attach. If you guys remember previously in IKE version 1, we only attach the transform set. But in IKE version 2, you need to attach 2 things: the IKE version 2 profile and the transform sets, the IPsec transform sets. So let's go ahead and do T set transform set. We name it T set and set the IKEV2 profile. We name that IKEV2 profile. And if you spell it wrong, it will tell you that it is not correct. It will tell you that it does not, the IKEV2 profile is not there. Just letting you guys know. Exit. So after that is done, what we want to configure is the tunnel interface. The tunnel is going to be the same way that we configure for IKE version 1, and we're also going to be configuring the EIGRP. So let's go ahead and do the interface tunnel 0 is going to have the tunnel source of gigabit 00. Tunnel destination is going to be 30.1.1.2. Tunnel mode IPsec using IPv4. Then we are going to be assigning that IP address of 192.168.1.1.0. Then we need to attach that IPsec profile, IPsec protection, IPsec profile, IPsec profile. And ISAKMP should come up. There we go. Good. Exit. Now we need to go and do router IGRP 10. No auto summary network. Before we do that, let's do show IP interface brief, so we can see that loopback address that we have. So we need to add this network and also this network. So network 2.2.2.2, and then network 192.168.1.0.255. Good, so now we are done with router 12. Now we need to do the same for router 14, and everything needs to match. If it doesn't match, then we won't be able to form that IKE version 2 phase 1 or IKE version 2 phase 2, which is IPsec, right? Exit. Now let's go ahead and go to router 14, and let's go ahead and finish this. You could either just go ahead and copy everything from router 2 and edit it, or just do it like I'm going to be doing it from scratch. Config T, and since we are going to be using, if we do a do show crypto IKEV2, IKEV2 proposal, you can see that proposal, the default proposal that we're going to be using. It is the same as router 12. And if you want to see the policy, which is the same as router 12, so we are not going to edit any of this. If we create a new one, a new proposal and a new policy, and we do a different encryption and integrity, then we need to match it to router 14. But since we're using the default, we are going to keep the default for router 14 as well. So what we need to do then is go ahead and create the crypto IKEV2 keyring. We are going to be calling this IKEV2 keyring. The name does not need to match as router 12, but since I'm used to doing the same, I'm just going to keep it the same. IKEV2 keyring. And inside right here, we need to specify a peer, and the peer is router 12. The address of the peer is 30.1.1.1, because it needs to be the IP address of that physical interface of gigabit 00. That is right here. After that is done, we need to do a pre-share key for the local. Remember that for the local is R14, and then the pre-share key for the remote is going to be R12. And as you can see right here, we're using an asymmetric keys, because we're using two different keys. It just needs to match, because in router 12 we specified the local to be R12, and for the remote we specified to be R14. Therefore, we need to do the opposite for router 14. We need to do the local R14 for the key and the remote R12, like that. And that is done. After that is done, what do we configure? We configure the crypto IKEV2 profile, and you can just name that IKEV2 profile or whatever you want. It does not need to match. And right here we need to do the authentication. We're using, for the remote, we're using pre-share key. Authentication for the local, also pre-share key, because we specify here on the keyring. Then you can do a keyring local IKEV2 keyring. Good. After that is done, we need to do the match identity remote address 30.1.1.1 and identity local address 30.1.1.2, right? The IP address of my remote. So that's good. We have now configured IKE version 2 phase 1. Now let's go ahead and configure IKE version 2 phase 2, which is IPsec, and it is the same as IKE version 1 phase 2. So we do a crypto IPsec transform set. We name this T set so we can keep it simple. ESP, this needs to match. Remember, we use AES 256 and ESP SHA, and we also use HMAC. We can go ahead and exit. And what do we need to do at the end? Well, at the end, guys, we need to go ahead and create the crypto IPsec profile, and we're going to name this IPsec profile. We need to set the transform set, T set, and are we done, guys? We are not done. We need to set the IKEV2 profile, and we name that IKEV2 profile. So done. We are now done with IKE version 2 phase 1 and IKE version 2 phase 2. Now what we need to do is we need to go ahead and create the tunnel and attach that IPsec profile to that tunnel. So interface tunnel, whatever you want. Let's go ahead and say tunnel 14. We are going to, you can do whatever first. Let's go ahead and do the IP address of 192.168.1.2/24. Tunnel mode IPsec over IPv4. Tunnel source gigabit 00. Tunnel destination 30.1.1.1. Good. And what is the last step that we need to do, or whatever you, or what are we missing? We need to do the tunnel protection IPsec profile, and we name that IPsec profile. And if you spell this incorrectly, it's going to tell you that it's not defined. But this one is defined, and it's not going to give an error. And you can see ISAKMP came up, and the protocol, though the interface also came up. And now we need to do a router EIGRP 10. And if you do it, do show IP interface brief, and I believe that IP address is 4.4.4. We did not specify a loopback, so let's go ahead and do IP loopback 0, not IP interface. interface, and then we do IP address 4.4.4.4. Done. Go ahead and go back to router EIGRP. Let's just go ahead and do another summary. Go ahead and do network 4.4.4.4, and then we do the network 192.168.1.0. And what do you think is going to happen? We are going to form an EIGRP relationship, and there it is. So now we are done. Let's go ahead and do a couple of commands that are going to be helpful. The first command is going to be to verify the IKEV2 SA. So you do a show crypto. What do you think we're going to do? ISAKMP? No, it's not ISAKMP. We're going to do IKEV2 SA. And you can see right here the tunnel ID of the local router 30.1.1.2, remote router 30.1.1.1. You can see the encryption that we're using. AES CBC, key size is 256. We are using for integrity SHA-512, Diffie Hellman group number 5, and for authentication we are using pre-share key. As you can see right here, PSK for pre-share key. And if you want to see the IKE version 2, phase 2, you can do a show crypto, and it's going to be the same because IPsec did not change. So IPsec SA, and there it is. Wonderful. Also, you can do a show IP EIGRP neighbors, and you can see that we have a neighbor 192.168.1.1, which is router 12 via tunnel 14. So that is good. You can also do a show IP route, and you can see that route 22.2.2.2 via 192.168.1.1 via the tunnel interface 14. Also, if you want to see that it is actually working, you can do, let's go ahead and do show crypto IPsec SA. You can see how many packets we have sent. So what I'm going to do now, I'm going to ping 2.2.2.2, and we are going to repeat it 100 times. And now you do a show crypto IPsec SA, and you can see that it increased by 100 because we sent 100 ICMP echoes to 2.2.2.2, and that went onto the tunnel. And if you want to verify that it's actually going to the tunnel, you can do a trace route to 2.2.2.2, and you're going to see that it is actually going to hop on that interface tunnel, and it's going to send it, and it's going to encrypt it via this interface right here, which is using IKEV1 phase 2 and also IPsec. And here we go. It is going via the tunnel 192.168.1.1. It is not sending that via 30.1.1.1, right? Because we specified to send it via the tunnel when we did that EIGRP and all that good stuff, right? So guys, I believe this is it for this video. I hope you guys enjoyed this video, and if you guys did enjoy this video on the IKEV1 versus IKEV2 configuration and how they are different, I did a small PowerPoint, small talk. I don't like to do a lot of PowerPoints, or I do like doing PowerPoints so you can see like a graphical or what I'm going to be doing, but I don't like to do a lot of just PowerPoints. I like to just do a small PowerPoints and then do a big configuration so you guys can see how it actually works. That's how I learn. I need to actually do it. I do not just like talking about it. So you guys saw how IKEV1 is configured, how IKEV1 is different from IKEV2, how IKEV2 is better than IKEV1, how you can use pre-share key to your certificate, how IPsec still the same even when you use IKEV1 phase 1 or IKEV1 phase 2. We configure this tunnel interface and all that good stuff. So if you guys like this video, go ahead and hit the like button. Also share this video with your mom, with your dad, with your wife, with your girlfriend, with the dog, with the cat, with whoever you want to share with. And also, if you like my videos, why don't you just go ahead and follow me on Twitter, guys. Go ahead and follow me on Twitter at CCNA Daily Tips, guys, if you have a Twitter account. If you don't, go ahead and create a Twitter account and then follow me on Twitter at CCNA Daily Tips. So thank you guys for watching this video, and I will see you on the next one, guys. Bye bye.